Good afternoon, Robert Scribbler. It is August 10th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now for this segment, I am going to answer the question, or attempt to answer the question, why are electrical vehicles surging ahead while sales of hydrogen fuel cell vehicles are lagging and being left in the dust? But before I do, I just like to look at some of the forecasts for electrical vehicles, which are looking better and better all the time. During 2017, according to Bloomberg New Energy Finance, approximately 1.1 million electrical vehicles sold across the world. And this year, it looks like we're on track to sell at least 1.6 million electrical vehicles globally. There are some estimates that that could be exceeded, but Bloomberg is a very good forecast site, so I just like to highlight their predictions. And in addition, according to Bloomberg New Energy Finance, the number of annual sales of electrical vehicles is likely to explode to 11 million by 2025, and then 30 million by 2030 as electrical vehicles become cheaper than the internal combustion engine. Ultimately, Bloomberg New Energy Finance estimates that more than half of the global sales fleet will be electrical vehicles by 2040. In comparison, the total number of hydrogen fuel cell vehicles sold around the world ever, so for total number in aggregate, not for any single year, but for 2013 to 2017, was 6,500. So less than 1,000 hydrogen fuel cell vehicles being sold per year through that period. This despite massive investments or massive stated investments by automakers such as Toyota and Honda, and a lot of verbal support by political leaders in places like Japan. So electrical vehicles from countries like China and automakers like Tesla are basically flooding out hydrogen fuel cell vehicles. Now why is this happening? Well, the first reason is that it's really just so much easier to put together a production chain and a fueling chain for electrical vehicles. The steps for energy transfer for electrical vehicles are from the sun to, and if we're looking at renewable economies, to wind and solar directly to an electrical vehicle. Whereas if you're looking at renewable hydrogen, first you need to capture the energy through a wind and solar system. Then you need to have an economic electrolyzer, which has not yet been produced. Electrolyzers are not yet economic. They haven't been produced to scale, and they're still in the pilot stage. So then you have to separate hydrogen from water and then store it as hydrogen. If you don't do that, basically your hydrogen's coming from natural gas, which is a high carbon intensive process. And that's the only way to mass produce hydrogen at this point on a global scale. So, I mean, even though there's some pilot electrolyzer projects that link to renewable power and produce renewable hydrogen, they're not yet being produced to scale. With the electrical vehicle, that process is just skipped entirely. The power goes directly to the car. Now, the thing is, once you produce the renewable hydrogen, then you have to distribute the renewable hydrogen, so you need pipes that are rated for hydrogen, trucks that are capable of storing hydrogen. Hydrogen is more difficult to store because it's a smaller molecule, so you need special coatings, and then you have to store it again at a gas station type location, which also requires extra infrastructure. And then finally, you transfer it to a hydrogen fuel cell vehicle, which requires a catalyst, which requires an electric motor, often uses batteries to store the energy that is produced by the hydrogen fuel cell. And then you also have to have special bottles that store the hydrogen in the vehicle. So, wow, lots of stuff to do with moving hydrogen around and managing hydrogen. So it's really hard to find a place that will actually give you hydrogen that you can use for a hydrogen fuel cell vehicle. But when it comes to electrical vehicles, where can you get electricity? Well, let's count the ways. You can plug in electrical vehicles at home. I'm going to check the time here. You can charge your electrical vehicle at work if your work has an electrical vehicle charger, and many workplaces now do. There are a number of shopping locations that now have electrical vehicle charging stations. There are superchargers, and according to this article in Electric, Tesla now says that 99% of the US population is now within 150 miles of a supercharger. And there are various other charging stations all over the place. And this infrastructure is growing, but in essence, anywhere where there's a plug, that's a place where you can charge your electrical vehicle. And that's a huge advantage that electrical vehicles have over hydrogen fuel cell vehicles. And that's just one of them. So the next time someone tells you that, oh, hydrogen is the future for vehicle-based transport and that electrical vehicles are production constrained, they're not really telling you the truth. The truth of the matter is that there already has been an economic competition between hydrogen fuel cell vehicles and electrical vehicles. And electrical vehicles are winning. In fact, electrical vehicles are now starting to become competitive with internal combustion engine-based vehicles on a number of levels. And over the next few years, over the next coming years, are going to start seriously outcompeting internal combustion engine-based vehicles. And in my opinion, hydrogen fuel cells-based vehicles will tend to lag. So just some things to think about with regards to the renewable energy transition and what are the most readily available technologies for us to rapidly transition away from fossil fuels. And electrical vehicles has proven that they can be mass produced and has a proven track record for what is known as a learning curve, a very fast learning curve, very fast technological learning curve. And this, in my opinion, is our sharpest edge option for outcompeting fossil fuels. So thank you for joining me, and I'll be chatting with you soon.